Okay, so section 1.5 is all about solving inequalities. The first box here, I'm pretty sure you're all familiar with inequalities. So I'm going to give you the inequality, the word, and then the graph. Okay, the most interesting part is probably the graph. So let's say, for example, we're going to deal with x is greater than 5. So the key term there is greater than. So the way that I want you to graph it is you got to give me 5, and you got to give me 0 somewhere on the number line, okay? So that line represents the number line here. And give me 0, give me 5, make sure 5 is to the right of the 0. Give me an open dot, and then go to the right because we want greater than 5. How is that different from B? Greater than or equal to 5. Since greater than or equal to, obviously give me 0, give me a 5, give me a dot, color in the dot, and then go to the right, and all is well. Less than 5? Alright, give me 0, give me 5, open dot, and we want to go less than 5, so we want to go to the left. We're talking about all values of x that are less than 5. Less than or equal to 5 works the same way. Give me 0, give me 5, give me the closed dot, and then go to the left. And that's everything you need to know for the first idea. Okay, here's the second idea. How do we write 5 fewer than a number is at least 12? So, well, first of all, we don't know what our number is, so let's call our number x, okay? If we want to go 5 fewer than our number x, then that means we have to subtract 5 from whatever number we have. So x minus 5 is at least 12. So it could be 12, 13, 14, 15. So it can be greater than or equal to 12. So this is how we would transpose that sentence into an inequality. Okay, take a look at this one. It says, write the quotient of a number and 3 is no more than 15. So again, just like we did before, let's start by giving ourselves a number. So the quotient of a number and 3. Okay, so that means that quotient means division. Alright. So we're going to go divided by. So we're going to say x divided by 3. That's the quotient of a number and 3 is no more than 15. So it cannot be bigger than 15, so it must be less than 15. No more than 15. But it could be 15, right? So we would have to say less than or equal to. So this is how we would transpose into an inequality there. Okay, we're going to now solve and graph this inequality, and we're going to start by doing our distributive property, so that we're going to get negative 6x plus 15 plus 1 is greater than or equal to 4. So that means negative 6x plus 16 is greater than or equal to 4. We're going to subtract 16 from both sides. And we're going to get negative 6x is now greater than or equal to a negative 12. We're going to divide by negative 6, divide by negative 6. Now, whenever you divide by or multiply by a negative number for inequalities, we reverse the direction of the inequality symbol. So therefore, x is now less than or equal to a positive 2. So when we graph on the number line, here's what you should have. You should give me 0. You should give me 2. You should give me a closed dot, and you want everything going to the left. So that's how we would solve that one right there. So there's the problem start to finish. Okay, so here's a relatable word problem that involves inequalities. So a movie rental company offers 2 subscriptions. You can pay $36 a month right off the bat and watch as many movies as you want, or you can pay $15 a month plus $1.50 each rental. Question is, how many movies must you rent in a month for the first plan to cost less than the second plan? Okay, so first of all, let's define a variable. Let's let n equal number of movies that we rent in 1 month. So it's important to define our variables so that we know what we're talking about. So for the first plan, okay, it's just going to cost us $36. That's all it says. Okay, so there is no variable in that. In the second plan, we pay $15 plus we pay $1.50 for every additional movie that we rent after that. So the question is, when will the first plan be less than the second plan? So the first plan is 36. When will that be less than the second plan, which is 15 plus 1.5n? When you solve this, you end up with 14 being less than n, or n has to be greater than 14. So to interpret, you must rent more than 14 movies in the first month for it to cost less. Okay, sometimes when solving inequalities, they have no solution, just like this one over here. So check this out. If I use the distributive property, I'd get negative 6x, I'd get minus 2, greater than negative 6x, and then plus 7. So notice the negative 6x is balanced on each side. So that leaves me with negative 2 is greater than 7. Is this ever true? No. So sometimes our inequalities have no solution. So whenever that happens, that's what you'd get. Okay, that's in contrast to this problem over here. So if I work this one out, check this out. We're going to get 10x minus 15 minus 7x is less than or equal to a 3x plus an 8. So 10x minus 7x, that's just 3x minus 15 less than or equal to a 3x plus 8. Notice that 3x is on both sides balanced, giving me negative 15 is less than or equal to positive 8. Well, this is always true, so that means that this inequality is always true. So all real numbers are solutions to that inequality there. Okay, sometimes we have to solve compound inequalities, or what we call AND inequalities. So we solve them both at the same time, so check this one out. If I subtract 1 from both sides, I would get 6 is less than 2x divided by 2 divided by 2. That means that 3 is less than x. I don't necessarily like to read it that way. I would rather read it like this. X is greater than 3. Now, why is that true, right? Well, let's see here. Well, 3 is less than 4. That's a true statement. And 4 is greater than 3. That's also a true statement. So as examples, I like to always have my variable on the left-hand side. So x is greater than 3. Okay, if we solve this one over here, divide by 3, I would get x is less than or equal to 6. So on the number line, when I draw these on the number line here, let's give myself 0, let's give myself 3, and then let's give myself 6. Is greater than 3. So we want to go this way, or less than or equal to 6. So less than or equal to 6. So the question is, where are both of these true? Right? They are both true. The overlap is from here to here. So any interval between there and there would give us where the both those inequalities are true. So I could have anything a little bit bigger than 3 up to 6 itself. Okay, the other types of inequalities are OR inequalities. So we're going to go ahead and solve both of them the same way. So let's say I'd have k in this case would be greater than or equal to 6 minus 7 would be negative 1, or k would strictly be less than, let's see here, 3 minus 8 would be a negative 5. Okay, so on the number line, if I needed to graph these, this is an OR statement, this is my number line. Here's 0, here's negative 1, and then way over here would be negative 5. So I want values that are greater than or equal to negative 1, so color it in, everything to the right of this, or I want values that are strictly less than negative 5, so everything over here. So everything I have shaded would be the correct way to answer the question there, and that's inequalities.